Good afternoon, all, and good morning, Robert, who's joining us at 5 a.m. your time. I'm Jian.
Good morning.
I'm a senior microscopist and image analyst here at Monash Microimaging. I'm coming to you today from the land of the Wurundjeri and Bunurong people from the Kulin Nation, and I will take this opportunity to pay my respect to the traditional custodians of the lands and waters on which Monash University stands. So for the first installment of the 2024 Monash Advanced Microscopy webinar, it is my great pleasure to introduce to you our speaker, Dr. Robert Haase. Robert is trained as a computer scientist and has been working on biomedical image analysis since 2008. During his doctoral research, he focused on developing swarm intelligence approaches to segment cancer cells in PET images. And after a first postdoc at the Scientific Computing Core Facility at the Max Planck Institute in Dresden, he joined the Myers Lab, still at the Max Planck. And you probably remember Loïc Royer, who spoke last year, who's also an alumnus in the Myers group. So in the Myers group, Robert worked on smart autonomous microscopy and GPU-accelerated image analysis. Robert is now leading the bioimage analysis group at the Technical University of Dresden in the Center of Excellence for Physics for Life. The group's mission is to make bioimage analysis sustainable and accessible to everyone, supporting experimentalists from image acquisition to analysis. The group embraces an interdisciplinary and collaborative philosophy to achieve their goal, establishing a dynamic conversation between all parties. And I must say it's a rather diverse and multicultural team, as one of the members is a cat, aptly named Pixel. Robert promotes image analysis through also his YouTube channel, which I suggest you check out, as it's a trove of lectures covering all aspects of image processing. Today, Robert will talk about prompt engineering for quantitative bioimage analysis and explain how generative artificial intelligence, particularly LLM, can be used to generate high-quality Python code and assist with image analysis. As Robert also serves as a lecturer, his talk will come with a practical component, so stay sharp. Please join me in welcoming Robert. Robert, all to you.
Hello, everyone. Thanks for having me. Good morning, good afternoon. So yeah, my topic today will be prompt engineering about quantitative bioimage analysis. And as you have heard already, well, let me just see that my keyboard works. By the way, you can download these slides. So the host will share the link in the chat. And then you don't have to take so much notes because you can download that stuff. So as you have heard before, my job is a bioimage analyst. So what I typically do, what I commonly do, if no cat disturbs me, I take microscopy images and then I segment, for example, nuclei, like you see here in this image. And then you can quantitatively analyze these nuclei, their parameters, count them. And the fun part recently, like the last year, 1.5 years, is that there was a technology coming up named ChatGPT, which can effectively do that. So the screenshot you see here is actually made by ChatGPT after uploading the image on the left and giving a prompt saying, please segment the nuclei in the blue channel of this image. So apparently, artificial intelligence is capable of replacing us to some degree. The AI can also explain what it was doing here. So there's also this explanatory text commonly, and you can click on this little button here on the bottom, to see the code which actually does that. So the AI is not like just coming up with something random and we do not know what exactly is done to the image, or we do know what exactly is done to the image because the artificial intelligence is producing code for analyzing the images as I would, maybe with a different quality, maybe with different library. So let's do one step back and have a look what generative artificial intelligence is. So generative artificial intelligence is a type of artificial intelligence that is capable of generating text, images, or other media in response to prompts. So this bridges the research field natural language processing and computer vision, and it is commonly based on neural networks. So use cases for that is, for example, translation. This is where the technology originally comes from. You take an English text and you translate it to German. Of course, you can also generate text, like writing emails, writing grant proposals. What I find more fascinating is when multiple modalities, multiple kinds of media come into play. So here you see, for example, how I take an image of noise, like really just random numbers, and a sentence like a picture of a cat in a microscope, and I put it into a neural network, into this architecture, and I can generate an image of a cat sitting next to a microscope. It also works the other way around. I can take an image where a cat is sitting next to a microscope and can ask the network, the language model, what is there, and it can describe this image. So there are these capabilities. It's all very fascinating with natural images, cats, and microscopes. Where I would like to go with this technology is that you put in a microscope image, you put in a prompt, and then you receive, for example, a segmented image in a sentence like, there are 4 cells. I just marked them. So that would be great if this technology could be developed to that degree that this works reliably. But there are some things to do, and I will also outline a little bit towards the end of my talk where the current challenges are. But how does it work in the very first place? I think here my animation is broken. Yeah. So how does it work in the very first place? So I have this, so this is technically what Stable Diffusion does in the background, just as an additional hint. So what I technically do, I have this neural network architecture and I am combining text information and image information. So images, when you talk to microscopy people, putting an image into a neural network is quite common. So you can do denoising with noise to void. You can do segmentation with cell pose, ScaDS. So this is deep learning based techniques which consume an image and produce some form of an image that can be easier segmented. So that's kind of like set. But how can you feed in a sentence? How can you feed in words? And there were some technological challenges necessary to solve first before we can combine these kind of information in one neural network. So what did the scientists in this field, what they came up with is the so-called word embedding, or also language embedding called sometimes. So you see here, I have this two-dimensional space. I hope you can see my mouse. You have this two-dimensional space between 0 and 1, 0 and 1, and I'm just visualizing that here with 2 dimensions. In real life, in the actual technology, it's something like 1,000 dimensions, but you can nicely explain it with two. And you see how the words black and white are close by each other because they are somehow related. They are both colors. And then when you look for example, for the distance between cat and fur, they are also related. Cat has a fur. The fur is mounted on the cat. They also can be both black and white. That's why this distance is quite similar. The fur can be white, the cat can be white, the cat can be black. Also, microscopes can be black-white. That's why it's a similar distance. But for example, the distance between the microscope and the fur is much larger because there are not so many microscopes which have a fur. So relationships between words and languages can be expressed in such a word embedding with distances. Again, typically they have higher dimensions. And you may now wonder, how do I come from a sentence like that to a word embedding expressing this information in this sentence? Also here for you need a neural network. And for training this neural network, you have to use another technology which is called self-attention. So if I want to take the entire internet, all the text on the internet, and I want to build such a word embedding for representing human knowledge, for example, I cannot just take entire sentences or entire text and then transform them into a word embedding. It would be too much information, the relationships between every word to every word. So I have to filter information out first. In order to do that, I weight words and sentences according to their relationship to another word. So if you, for example, look at the word white in the sentence, the cat's fur is black and white. If you look at the word white here in the sentence, there's some relationship with black and end. They are, again, it's a list of things. They are somehow related. Also, the word is and fur have a strong relationship. They are kind of, they need attention. They are related to each other. But for example, if you look at the word that at the beginning of the sentence, it has nothing to do with the white at the very end. And in that way, you can focus this training of this neural network towards the relationships in sentences which are important, which are where there is a relation between the words. And if you now wonder how is the self-attention made, of course, also with a neural network. So some years ago, we were speaking about you download a neural network architecture, you put in some images, you train the network, and then you have your neural network, which can, for example, do denoising or segmentation. That's what many people nowadays also do in daily life for analyzing data, training one network. Now here, this technology, we need to train a network in order to train a network in order to train a network. So we combine multiple different kinds of networks. They are architecturally very different from each other. We are now combining them in huge architectures, which then are called large language models. So it's quite fascinating from a computational perspective how these things are taking over the technology and how complex they actually are. So really fascinating network training for training networks for training networks. Let's talk a bit about what large language models are good in. So, for example, that's again where the original technology comes from, good in translating text. So you can, for example, what is every parent's favorite Christmas song, Silent Night? You can translate that to German. ChatGPT can just do that. You can also use it for restructuring data. This is a use case I think is not often enough discussed because I believe this is the actual power of large language models is transforming information in the text form into another form in another shape which is easier to digest for further processing. So I have here a sentence or a short story. The Computer Center of the university recently conducted a study to figure out the needs of students for computational resources. After interviewing 100 students, they concluded that most of them were happy with 250 gigabytes of cloud storage. And I asked ChatGPT, can you please summarize this text to just these two key information, number of students asked and cloud storage size. And you see that below the gray box on the bottom, the ChatGPT will just respond with that. So imagine you have a lot of text sources like multiple books or multiple submissions from students, some tasks they had to do during their studies, and you just want to extract the key information if they got the result right. You would sit an entire day for reading all that stuff, or you can ask ChatGPT to automatically do this. So the power here is extreme. That's really, really huge. It's an enabling technology. What is it not so good in? So, for example, in receiving recent information or receiving information in very general about people, about things, about relationships of physical principles, it's not exactly very good. I have here this one example. There's also a minor correction to what we heard at the very beginning. I'm no longer group leader in Dresden. I'm now lecturer in Leipzig, which is something like 150 kilometers away from Dresden. So I just moved to a different city. So if you ask, what is Robert Haase's research field at the University of Leipzig, where I live now? ChatGPT will respond something like, I couldn't find any information about Robert Haase from the Leipzig University. It's possible that he may not be prominent or well-known researcher in the field. But if you ask it for what is Robert Haase at TU Dresden doing, it can then tell you that he is working in computer science and medical image analysis, which is right to some degree. So receiving recent information in particular is tricky because language models are commonly trained on the state of the internet in the past. So I think the current ChatGPT is trained on all the data which was available around Christmas last year. Um, there's always some kind of delay. Here, I'm in particular proud that I can present this slide to you today because I'm carrying it around for some time, but nobody down under has ever seen it, I guess. Um, how many O's are there in Wulu Mulu? Well, it says sometimes six or five or seven. Sometimes it may say eight, which is right. But here you can nicely see that this language model, which is built to assemble text, to transform text from one form to another, is not capable of counting. So now imagine instead of putting text in where the information is quite simple structure, imagine you take this technology to put a microscope image in and you ask for how many nuclei are there. That's extremely challenging. That's extremely complicated. Language models may not be for this kind of task. So they may never be developed to a degree where they can solve these kind of problems. There's other models which are much better in this. So that's why I have it here on my list. So in order to get the best out of the language models as they are at the moment, there's a term coming up, prompt engineering. And there are people, maybe I am already one of them, who are prompt engineers, who can basically take the text which is fed into the language model and modify it in a way to get the best out of the language model. So modifying this prompt, they are prompt engineers. And I have here again an example, and I have to move myself around so that I can actually read it out. So first, you have to assign a role to the language model. You have to give some context to tell the language model in which situation it is. You are a professional academic consultant who gives advice to students for writing their thesis. Give these hints. And then I have these 3 hints listed, which I would like to give to the master students, but I would like to transform this text in whatever way. So that's listing tasks. So I have to tell it in which situation it is and what it is supposed to do. And if I then submit this prompt, I will get a ChatGPT typical answer like this. Blah, 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 blah. It's commonly producing a lot of text. Also very, very detailed, maybe even repeating itself, and it's like not very concise. So maybe the first thing you should do, you should define the output style you want to have. You can say, please keep it short. And then the response will be something like this. And this is maybe already much better. And you can shape this output in various forms. You can, for example, say, please write like Yoda would. From day one, start writing your thesis, you must. So it is also capable of doing this. And you can use translation. You can ask it to do this in German, in French, whatever, and the results will be reasonable if it is a common language. Not every language in the world is like technically possible with this model. And what I would also highly recommend, in particular when you are a programming beginner, you can do things like, here's some Python code. Can you please explain me this Python code like if I was a 5-year-old? And it will do this. And that's at least what the students in my course also enjoyed a lot. You can ask questions about simple Python stuff again and again and again, as often as you like. And ChatGPT will be very patient. It will take the time to respond to you, to explain you everything in very detail. So in particular for the people who may be a bit too shy in a course to raise their hand and ask, can you please explain me the for loop again? That's a great tool. ChatGPT can help, in particular Python beginners, a lot. So you can also produce images. Now we are coming closely to the bioimage analysis field, but not yet. So we would like to have an image of a cat sitting behind a microscope. If you do that, you get, for example, these images out. Disclaimer, no cat was hurt when producing these images. Um, and one of them is real. And maybe it may be easy to identify this one cat. If it might also be easy, it would also be easy if it was not a popular one on Twitter. Because these images look very different, and if you look closely, some of them might not even represent a physically possible scene. So if I want to fool, for example, somebody who looks at these images and has to guess which one is right, I have to provide a much more detailed prompt, as I was mentioning before. So here the prompt is now the following. Image of a cat sitting behind a microscope. Both are on a brown floor in front of a white wall. The cat is mostly white and has some black dots. The cat sits straight and the cat is a bit larger than the microscope. But if you ask a prompt like this, you may then get images out which are more similar to the scene like the one you were describing. That's prompt engineering. You modify your prompt step by step to come closer to the result you want to receive. So I've seen, and I'm in this discussions again and again that somebody tried out ChatGPT and it was responding with something stupid, or the result was not very good. Yeah, you have to try harder and you have to provide more information. And one should not use ChatGPT as a Google replacement because it's not what it's meant for. It is basically a tool for transforming information from one form into another form. So it's not for searching, not for searching the internet. Yeah, so and the more precise you do that, the more information you provide, the better the result will become, the closer the result will be to what you expect from it. Yeah, and you can produce code. So after we produce text to receive information, you can produce images and you can produce code. And this is what is very interesting for me, also from the science perspective. So here in this case, I'm asking ChatGPT, can you please provide Python code that loads the file blobs.tif that segments the object in this image, labels these objects, and visualize the results. And if I run this, I receive some Python code, I can execute this Python code, and the result will look like that. So obviously it is capable to solve these kind of simple image analysis tasks, which were to some degree daily business of my job when I was like a full-time image analyst. If you make this task more complicated, so that's pretty much the same task, but I would like to draw a mesh between the labels with a maximum distance of 50 pixels. So a lot of people, at least in my Dresden environment, a lot of people were studying how tissues grow, how they develop over time, and relationships between neighboring cells. So this is basically one example from this space. So that's quite complicated. ChatGPT itself cannot do this. It does not know how the code looks like, which can do this kind of analysis. And we will also see examples later. So you have to provide a more detailed prompt. So first of all, I put this additional context there. Please write Python code like a professional would. And now I'm moving myself around again. And furthermore, I provide code snippets. If it does not know how to do stuff, I can just provide code snippets. So this is a code snippet for drawing a mesh between objects in the label image, between neighboring objects in the label image. So and then there's one line of Python code. And then I can ask the language model, can you please try to do this task? So you see a simple question on the left and a more complicated, a more sophisticated question on the right. And if I was, when I execute them, you see here the first time I run the more sophisticated question, there's an error message, so it doesn't work. I could now drop and I go home and say ChatGPT is a stupid thing, but I run it again. So the second time I execute this code, there's a result which looks reasonable. So I do not see the segmentation, unfortunately, but I see the mesh, and that's what I asked for. Then there are error messages again in attempt number 3. Attempt number 6 works, 9 and 10. And yeah, so there's differently looking results. Sometimes I see the segmentation, sometimes I don't. And in summary, the more sophisticated prompt results in useful results. So the code which is generated produces useful results in 5 of the 10 cases, in 50%, and error messages in 4 of the cases. And the simple question without this additional hint did not work at all in none cases. So just by modifying the prompt, by providing more information, I can basically give ChatGPT the capability to solve this more complicated problem. And you can do this in more or less in the browser by going to ChatGPT, to the website, uploading your image, and then saying, here, segment this image, please. And it will then come with a result. You have also seen it at the very beginning of my talk. Sometimes they look different, these results. So here, this time, it looks like that. And there's this button where you can ask which is the code for doing exactly that. And then you can reproduce it on your computer if you like. It's a bit limited though, if you think about more advanced stuff in the microscopy field. So that's why I came up with the bioimage analysis GPT. This is a screenshot, the one on the left here I took this morning. So an hour ago. And you see here on the very bottom, bioimage IO chatbot is out. It's a new thing. I have not seen that before. I've seen talks about it, so that was about to be released. So that's a very new thing. And there's also the bioimage buddy and the bioimage creator, which sounds a bit like, ooh, is there some scientific stuff behind? So let's try out these things. So there are multiple custom GPTs which you can try out, which have additional knowledge on top of ChatGPT. So let's quickly compare how ChatGPT performs in comparison with the bioimage analysis GPT, which I made. So again, if you ask ChatGPT a question which is a little bit out of the space of the stuff it can do, how can I measure the number of neighbors in a label image? Similar to the question before, which it was not capable of solving. It will again come up, yeah, the animation works. It will again come up with a very long response and a lot of blah, blah. And then by the end, there's some code. And if you look at this code carefully, Um, here you would implement the logic to check neighbors for each region. It does not know how to do this. That's what I said earlier. This time it also tells us. So it does not have the knowledge for implementing this. So that's why I started working on that and improving here on this particular front. So ChatGPT itself, long responses, and it does not know this kind of special knowledge we sometimes need for analyzing microscopy images. If you ask the bioimage analysis GPT, which is the same user interface, yeah, in the browser, same website, you can enter the same question. You will get more concise answers, and there will be also code snippets for these kind of these particular questions, which are more closely related to bioimage analysis tasks. So it can then do this. Still the same technology, just an additional knowledge base in there. And this knowledge base is based on the bioimage analysis notebooks I'm maintaining now for a couple of years. So what I'm saying here on this slide is if you have the feeling that there is particular Python knowledge you analyze images of different kinds like I do, and you say, it would be great if the stuff I do on a daily basis would also be available in the bioimage analysis GPT. You can submit the stuff you do in the form of Jupyter notebooks to this resource. So we make it part of the bioimage analysis notebooks. You become co-author, all good. And then the bioimage analysis GPT will be aware of the Python libraries you are using, will be aware of the code snippets you provided. So you can extend this thing if you like. Yeah, there's one more way for using this technology, because if you want to use ChatGPT in the web interface, you have to upload your data. And that's at least according to European data protection laws, not so very good. That's why we started here with Christian Tischer in Heidelberg. I started working on this, and maybe I will start this video again. You can say, Bob, load blobs.tif and show it. That works in Jupyter. It will then generate a new code cell, which does exactly that. You can execute this code, and then you can ask next question, Bob, please segment the image and show the result. And it will again produce code. You can read this code, you can check it carefully, you can execute it, and then you will have a segmentation result, for example. The good thing about Bob is that also you have the code in a notebook already. You can keep this notebook. If you execute the code in this notebook tomorrow, next year, the result will be the same. If you ask ChatGPT again next year, I presume the results might be different. So that's why I keep the code and not also maybe keep the prompt which generated the code, but keep the code, which is more important because it is reproducible. Um, so here you see BioBob, that's the technology, how we call it, bioimage analysis Bob. You can use it with ChatGPT. You can also precisely define with which GPT version, GPT-4, 1106, I was using here to produce code. And you can also use it, for example, with Google Gemini, where recently more people are talking about. And here you see both solve this problem, both produce code for answering this question. But Google Gemini in this particular case is using weird variable names. I also sometimes see that import statements are a little bit different than a common Python programmer would do it. So I would say some unusual examples are in there. So they may fix it over time, or it may just stay different for longer. That's all certainly possible. You can also use this technology with BlaBlaDoor, which is maybe not so relevant for Australians. But if you were a German academic or if you have an affiliation with a German university or a German research center, you can use this infrastructure for free. It's basically an OpenAI kind of server which which allows to run open source models. So you do not have to buy fancy infrastructure or expensive graphics cards to do that yourself. You can use this publicly available infrastructure for German academics, unfortunately. You can also use Olama here on the right to run a model locally. So that's all. I would also say there's a lot of development recently, and we will further develop these kind of things, but you do not have to stick to the ChatGPT infrastructure and upload your data there. You can also run this entire locally in your private space with these open source technologies. But I also must admit that the open source models which produce code appear to me less capable than the commercial systems. The commercial systems were in training very, very expensive. They spend a lot of effort. So the produced code from these systems is fantastic. The open source models can solve simple tasks. Let's say it like that. um, and now we are moving forward. So far, I presented prompts. I was with text describing what I would like the language model to achieve. And now I'm providing additionally images. So you see here, I say, Bob, image. So I'm basically uploading this image. And then I ask, what's in this image? Answer in a short sentence. And based on ChatGPT, so ChatGPT supports image input and text input combined. And then the result will be the image shows a black white cat sitting next to sitting next to a medical device, possibly an automated peritoneal dialysis machine. So sometimes it also says microscope. If I ask Gemini, which also has the capability to consume images, it may say something like a cat sitting next to a microscope. I know that this feature at the moment in Biobob is broken, but the bug fix is on the way. So if you try it out in a week or two, it will work again. So we are also working here on having the same capability with open source models where there is a huge opportunity to again run these things locally. So there's work in progress that's not available yet in this library. You cannot, I mean, you can download this particular branch from GitHub. Also, if you're a Python programmer and you are interested in that, so that's from a science perspective, maybe what is the current research front. So feel free to join efforts. I'm developing this in the open. Yeah, and it's fun. Good. So again, where I would like to come is that we can provide a microscopy image, and then we say, hey, look at this microscopy image. What is in this image? So then ChatGPT may respond something like that. There are nuclei stained in blue. Awesome. And then there are actin filaments stained in green, and what is likely to be mitochondria stained in red. And I think it mixed up these two. Does not know that. But maybe it is indeed possible to train models, to fine-tune models which are more aware of microscopy context, which are better in microscopy image interpretation. And if you can have a language model which has some knowledge about how to segment nuclei, and if you have a language model which can see in an image that there are nuclei, you could have prompts or you could have generated code which fits much better to the images you want to analyze. In particular, for the people who may not be super experienced in image analysis yet, this might be a useful tool. You provide an image to a language model and say, here, can you please tell me how to segment these nuclei or these objects? And then the language model will itself see that there are nuclei and it will know how to segment them. So that's the interesting research part. There's other techniques which offer similar capabilities. So I've just learned this morning that Louis Coyer was presenting in your seminar series. So you know about ChatGPT already, which is in Napari. So I can also highly recommend that. Loic's vegan project was at the very beginning. I think, let's see if this video plays. I think he now spends more time on it than just working on the weekend. So here you provide a prompt as well, and then it will generate code which produces a Tapari plugin, an interactive user interface, which can segment nuclei. And then in this user interface, you can click on run, and it will then give you the result in the Napari window. I think compared to what we do in the Jupyter space is that here you may not be easily capable of modifying the code so before running it. But in very general, the technique is the same and the ideas, the underlying ideas are the same. I must really say here that I was inspired a lot by Louis' work on Napari ChatGPT when I made the stuff for Jupyter. The same things will also come to Fiji, but here, so which is great, in particular for, I can highly recommend it for commenting code. If you get a lot of, if you get a long image J macro from a collaborator and it is not well documented, you can ask ChatGPT, can you please write comments in this code? And then it will write comments there. It will explain what the code is doing. Again, this might be for Python, for image J macro beginners. It might be a cool tool. But I must also say that ChatGPT's knowledge about image chain macro is limited because the online documentation about these techniques are limited compared to Python. And that's why it often, if you ask ChatGPT, can you please produce image chain macro code which does this and that, it often fails. It produces code certainly, but this code will not run in image chain because yeah, there's less knowledge about image chain macro on the internet in the training data for ChatGPT compared to Python. So here I must clearly say, go for Python if you can, use Napari and maybe leave the anyway limited programming language image chain macro behind. What else can you do with these techniques? And now we are slowly leaving the field of reasonable research. What we still can do is we can take one image and modify it in a way. So image variation is the term here. And then we have multiple images which look a bit similar. And we can test, for example, segmentation algorithms if they are capable of dealing with both kinds of images. So that for producing more training data from a small amount of training data, that's great. And at some point it becomes art So you can, for example, modify an image so that the gold particles in this image, maybe nuclei, look more cat-like. So that's great, but maybe that's more art than science. But fun anyway. By the way, you can download all these notebooks and run this stuff yourself and reproduce it. And if you can produce images, you can also do this. And this is where I would say there are interesting challenges ahead. So I asked a friend, a colleague of mine, Jan Brocher, is a bit an expert on this, how to identify images which were manipulated. And while it was quite easy, if somebody crops a cell from one image and moves it to another image, or uh, that was kind of easy to detect, or there were techniques for doing this. If you do this with artificial intelligence, with generative artificial intelligence, you produce a microscope image or you just replace one cell by another, it's technically much harder to detect. So here we have to develop new technologies. Here we have to come up with proper solutions that we can avoid that people use this in a wrong way. So it's kind of dangerous what the technology brings here, but it's often with new technologies that these things happen. So I spoke already a bit about data integrity. Also, we don't want to upload everything to the server. Like microscopy image data uploading to OpenAI is technically not possible anyway because you are limited to a certain amount of data. So you cannot upload a 50 gigabyte data set and then analyze it on their server. So you have to run this locally anyway. But I also would like to highlight here a little bit that if you, for example, work with patient data, you are a physician and you want to basically let ChatGPT write an email to a patient telling them about their disease, never ever enter patient names and diseases in ChatGPT prompts. Yeah, so that's privacy related. This stuff will get uploaded to the OpenAI server to a company in the US, and they will do something with it. So please be very careful with what information you provide and do not share in particular person-related data to language models which run remotely. Then there's also the issue of computational cost. So it looks a bit like we are currently heading to a point where the training of large language models costs as much energy as all the other humanity on Earth. And I'm not sure if you want to go there. So maybe we should spend a little bit more effort into figuring out how to do these things in a sustainable way. There's also bias in these models. So here I was using Stable Diffusion to produce images, to produce nice photos of humans. And I must admit, I was surprised when I did that half of them were male and half of them were female. That was already a positive surprise, but they're all white. So maybe this is not a perfect representation of humanity, of a human. So here there's some bias in there. It was also with Google recently discussed. You can also produce their weird images. It does hallucination, so it sometimes comes up with information which just gets wrong. So this here is, by the way, taken from my interview. This is a slide for my interview when I was in Leipzig for the position I have now. And I asked ChatGPT, who developed Hadoop? And it said, yeah, there's a group in Potsdam, close to Berlin in Germany. But in fact, Hadoop was developed by the group in Leipzig where I was interviewing it. So if you asked ChatGPT a year ago, it came up with some wrong answer. Today, the answer is right. So I did not test this in very detail. I cannot tell you that n equal 1. I cannot tell you how often it responds right or wrong. But I have the impression that the developers of these models put a lot of effort into reducing hallucinations, reducing false information in responses to prompts. So that's getting better, but it will remain a challenge, a technical challenge, certainly for some time. Also, debugging is hard. You have seen it earlier, prompt engineering, modifying a prompt until it really does what you want it to do, it takes time. And it's a different task compared to programming Python. If you call a Python function and it does not what you want to do, you can read the documentation, you can change the parameters, and then it may do what you want it to do. With prompts, it's different. You have to play a bit around, you have to test a lot, and you have to get some feeling about how these language models work. I also have the strong impression that the different language models follow different rules. So Gemini works very different compared to ChatGPT if you modify these prompts and want to get the same result out. And so here, that's like a new challenge which came with this technology. There are some more videos if you want to learn more. I can strongly recommend the YouTube channel of Digital 3, a guy from San Francisco, or close by San Francisco, who explains all these techniques in very detail and also provides Python code so that you can try out with small experiments these individual small technologies for, yeah, for example, for training a language model. You have seen Louis Croyer's talk about ChatGPT, and here is a YouTube video where he explains it in more detail. And on the right, there's two more videos about generative AI and how this technology works from a colleague of mine, and also from myself, where I was explaining that a bit more in detail earlier. Ah, yeah, and you have a duplicated slide. That happens. As said at the very beginning, I provided some exercises for you. So we will certainly not do them now. But if you feel like you can certainly do that as a homework afterwards, I will just quickly go over it. So here are some installation instructions. If you want to do anything of the stuff I showed you in my slides before, if you want to do this on your local computer, you have to set up MiniForge. That is a Conda environment. Again, there's a link on the bottom of the slide, and you can download these slides. And there is a step-by-step guide of which commands you have to execute in order to get an environment where you can then run the code, which you can download from my slide. You have to go, if you want to go the OpenAI way, you have to sign up there and you have to enter your credit card number in order to use this technique. I also strongly suggest to put a monthly budget. So I think the default is something like $100, $120. If you say, I would like to spend maximum $10 this month or any month, you should put this number there. And then, as a kind of realistic estimation, when I was for the very first time preparing slides like that, I was for a week, maybe not the entire time, but maybe half day. I was executing some prompts, changing the code a bit, executing the prompt again. And I was towards the end of the week, I spent something like $4. So executing a single prompt costs less than a cent. So if you just want to run some notebooks, if you maybe want to download all the notebooks here from my talk and just run them once, you may pay 10 cents. So it's like not big money involved here. So feel free to do that, but yeah, obviously it costs money. Yes, you have to create a so-called API key, and here's some arrows and buttons where you can do that. And then on Windows, you have to enter that in the system environment of your computer. If you work with Mac OS or if you work with Linux, that may work a little bit differently, but you can find this information online. Yeah, then afterwards, you can download these notebooks and you can run them. So, for example, you can run these notebooks where I was producing text. You can ask ChatGPT to count how many O's are there in Woolloomooloo. And you can also try Bayabob to produce some image analysis code. And you can even use the vision models, uploading an image and then asking ChatGPT how to analyze this particular image. If you do that with multiple people in a room, that might be in particular interesting because if you execute the same notebook, the produced code may be different and the result might look different. So you have, I think that's now the third or fourth time I show an example how to segment blobs.tiff and visualize the result. And it always looks a little bit different. Be aware that code which comes out of the language models varies, but the code afterwards is stable and reproducible. Good. With that, I would like to thank a lot of communities. I also would like to thank my group in Dresden, which I unfortunately had to leave behind. It was great to work with them, and I would like to thank you for your attention, and I'm open for questions.
Thank you so much, Robert, for this very exciting and educational talk. And I would like to say I'm sorry about missing your new affiliation, and I did not use GPT
All good.
to
All
create
good.
the intro. Cool. So if anyone has questions, let's go into the Q&A. So an anonymous attendee asked, is the image segmentation done on GPT 3.5 or 4?
So I commonly use GPT-4, even though also 3.5 can produce nice code. Christian Fischer had some experience that there is. So we are using GPT-4 for two reasons. One reason is in Biobomb. One reason is it knows more about more recent Python libraries. So there was some stuff published after OpenAI 3. ChatGPT 3.5. So that's why we are using 4 because it has more knowledge. And the other technical limitation is that so you have seen that if you want to have Python code which executes with a higher probability to analyze complex tasks in image analysis, you have to provide code snippets. So what Bob does under the hood, it is providing something like 100 or 150 code snippets. So that's a huge prompt. It's like half a book or something. And in order to make this long prompt work, you need to use GPT-4 because GPT 3.5 is limited in the prompt length. So that's why we are using 4 commonly.
Cool, thank you. Any more questions? Yes, so Charles is asking, what challenges remain before this approach move from an educational or hobby tool to a serious element of image analysis workflows? How long realistically do you think it will until this happens?
So on my desk, this transition has happened already. No, seriously, I spare a lot of time, in particular when it comes to simple tasks. So if you find yourself, for example, you have a folder of ScaDS.AI images or any format from a vendor from Microscopes, and you want to convert all these images into TIFF because you want to process them in a certain software, you can just say, ChatGPT, please produce code which does this conversion from this format into that format. It will then produce 10 lines of code, and they will run with a very high likelihood. So, and for these kind of tasks, so this is, from an image analyst perspective, super boring. Like the first you can do it. For these kind of tasks, ChatGPT, in whatever form you use it, in the browser or via Bob, or maybe also in Apari ChatGPT, these kind of tasks, eh, I don't think that many people will still write this code themselves. I think this is code which will be generated now or in the future anyway. So ChatGPT is really, really good at these basic tasks. Yeah, and the more complex tasks, let's see. I know plenty of research groups actually who are currently investigating how to make ChatGPT more capable in a niche like bioimage analysis. So there's multiple groups working on that. You know, the typical length of a PhD thesis is something like 3, 4, 5 years. So I would expect in that time frame some cool publications coming up where then these models become really capable in, again, niche tasks, very specific to image analysis, for example.
So when Loic spoke last year, he emphasized the fact that whilst these were tools, they actually require quite a lot of knowledge in image analysis. So if you didn't know anything, you couldn't just go and ask ChatGPT to do it. Would you concur?
No, I think so too. We can eventually focus on the scientific part, on image analysis, and we do not have to think a lot about how the code has to look like for implementing this particular thing. We still need to know which algorithm is capable of doing what. So we still have to, for example, provide this information to ChatGPT. ChatGPT, I would like to segment the nuclei with cell pose. And then ChatGPT will come up with the right code. If you just say, ChatGPT, can you please segment these nuclei? It may come up with an algorithm which is outdated, and then the segmentation will not look very good. So I would say we can eventually focus again on on the actual task and the algorithms behind. Therefore, we need special knowledge. We will still need lectures about image analysis, but we may not need the lectures or may need them less about Python programming. So that may go
Yeah,
away with time.
democratizes a bit more the
Mhm.
coding. So Juan is asking, do you know what are the techniques used to support longer prompt length? I've run into that issue very quickly with free open source models, but couldn't find a good answer online quickly.
Yeah, so I'm not sure if for the open source models this problem is solved. There is a technique, I think it's called something like ring buffer, which offers unlimited length. It was also a major impact in the field that you basically You have a sliding window moving over your prompt, and the model is basically consuming the input from this sliding window, which moves over the text. So this technique uh, may solve this problem in very general for all models. And I know that this is open source. It was like published a month or two ago, but I don't think that I have ever seen an open source implementation which uses it. So that's just too fresh, too new. And in the meantime, we may have to stick to models like GPT-4, Gemini, which can consume these extremely long prompts. I think the longest thing which is available at the moment is Gemini, which can consume something like 1 million token or something like token is a word, by the way, approximately.
Thank you. So Runa is asking, what happens when ChatGPT helps invent the new image analysis process? How do you define credit? How do you attribute, I guess, credit for such advancement?
Yeah, that's so I'm actually not sure what German or what European law says about these things, but I find the American way of interpreting this very interesting. It is hard or impossible apparently to put copyright on something that was generated by an AI. Because if an AI produces an image, for example, this image cannot be copyright protected. You cannot restrict the usage of something that was not produced by a human. It's American law, apparently, and I find this very interesting. And I think also a lot of journalists argue in a similar way. ChatGPT cannot be an author of a paper because it is not a person.
Yeah, because that was
And
the
I would
case
argue
early
here,
on. A lot of people
yeah,
were putting them as authors.
exactly. So at the end, ChatGPT is just a tool you were using. It's a very advanced tool compared to the tools we had before. But also, if you, for example, use auto-completion in Word to write a paper, you would not even mention that when submitting the paper. So maybe ChatGPT will end up as a similar tool, which is just used by the people.
So maybe just in the material and methods section.
Maybe.
I think that's all the questions that we have for the moment. Anything else? Oh yeah, no. Charles is asking regarding the challenges around data manipulation. Are you aware of any efforts to directly address this? Example, there is already an arms race to generate code that can detect AI generated text. I mean, you alluded to it in your talk.
Yeah, in particular in the text field, there's many research groups working on that. We also have it at the Institute and multiple groups actually working on ethics and how to make things safe when you think about AI. I'm not aware of a research group who is particularly working on the AI, the generated microscopy images topic. I presume there are, but I'm not aware.
Thank you. And so Neha is asking, is there any way we can know if the code is generated by human or AI?
Uh, I think if you generate code for some time with an AI, you will develop a gut feeling. But I'm also here not aware of a technology which does it. I would ask the counter question, why do you want to know that? Why is it
Yeah, it doesn't matter.
necessary to know? Why is it necessary to know if the code was written by a human or if it was generated by an AI? Would love to know the use case behind.
Mm. I think that's all. That's all for today. No more questions.
Thanks for having me. And
For
also,
joining,
if you execute this homework later on, feel free to ask a question via image.sc. Open a thread, put a link to the notebook where you struggled with something, where you have a question, and I will respond.
Thank you so much, Robert. It was an excellent talk. And thank you also for getting up so early for us. And
You're welcome.
thanks everyone for attending. And hopefully we'll see you at the next installment of our webinar. Thanks, everyone. Bye.
Have a great day. Bye bye.